the number one team that's made up of Hernandez Garcia Estivalis, Lopez Rueda Melina, and Tapia Sanchez Ingrid, students of the Autonomous University of Tamaulipas.
In this video, we will explain what the transport model is and we will give an example of how it is done. The transportation model is a special kind of linear programming that has to do with transporting an item from its source to its destination. The objective is to determine the transportation program that minimizes the total cost of transportation while meeting the limits of supply and demand.
The model assumes that the cost of transport is proportional to the number of units transported on a given route. In general, the transportation model can be expanded to other areas of operation, including inventory control, job scheduling, and staffing.
The general problem is represented as follows.
There are M source and N destination. H source and H destination represented by a knot. The arcs represent routes that link to source and destination. The arc that joins source I with destination J carries two cans of information: the cost of transport Cij per unit and the quantity transport Xij, the quantity of supply at source Isi, and the quantity of demand and destination Jbj.
The objective of the model is to determine the unknowns that minimize the total cost of the transportation and that at the same time satisfy the supply and demand constraints.
Example: MJ Auto has 3 plants in Los Angeles, Detroit, New Orleans, and 2 main distribution centers and Denver in Miami. The capacities of the 3 plants during the next quarter will be 1,000, 1,500 and 1,200 cars.
The quarterly demands in the 2 distribution centers are 2,300 and 1,400 cars. The mileage between factories and distribution centers in the following table.
The truck company charges 8 cents per mile and per car. The cost of transportation per car on the different routes and rounded up to the nearest is calculated and is known in the following table.
The linear programming model for the problem is as follows.
All restrictions are equations because the total supply from the 3 sources equals 1,000 plus 1,500 plus 1,200 equals 3,700 cars is equal to the total demand and they solve it at the simplest method. However, the special structure of the constraint allows the solve it more comfortably using the following transport table. The optimal solution indicates that 1,000 cars are sent from Los Angeles to Denver, 1,200 from Detroit to Denver, 200 from Detroit and Miami, and 1,200 from New Orleans to Miami. The minimum cost of transportation to member is 1,100 times 80 plus 1,300 times 100 plus 200 times 180 plus 1,200 times 69 equal 314,400.
The transport algorithm is based on the hypothesis that the model is balanced, and that means that the total demand is equal to the total supply. If the model is unbalanced, it can always be augmented with a fictitious source or a fictitious destination to restore balance.
Example, in the Able model assumes that the Detroit plant capacity is 1,300 cars instead of 1,500. The total supply equals 3,500 is less than the total demand equals 3,700 cars, which means that part of the demand in Denver and Miami will not be satisfied.
We can also demonstrate the case in which the supply is greater than the demand, assuming that in Denver the demand is only 900. In this case, a fictitious distribution center must be added that receives the excess supply. As low the unit cost of transportation to the fictitious distribution center are zero unless other conditions are desired.